Okay, okay. Sorry, thank you. So this is actually just to show you those who are watching recording. I'll just go back and start from where I stopped. Economic equivalence, the definition, and then we looked at how do we calculate an economic equivalence, that 100 now is equal to 110 in the future. So 100 and 110, they are equal. Why they are equal? It is because of economic equivalence. What made them equal? 100 today is same as 110 after 1 year. Economically they are equal because of the interest rate and the time using this formula. So whether you get 100 now or 110 after some time, it is same. This concept we call it economic equivalence, and this is the formula which we just discussed. This is another example. How do we solve it? Now for example, another example here another question. What if you have to find a p? F is given and you have to find a present value. For example, it says here a small company wants to make a single deposit now. So they want to deposit some money today. Now you want to deposit something now so that it will have enough money to purchase, let's say, backhoe costing some machine 5,000 5 years from now. You have some extra money and you want to deposit it for some profit at an interest rate of 12% for 5 years, so that after 5 years you have this much money. Okay, now 50,000 you will need it after 5 years. How much you must deposit at some profit rate so that you could have 50,000 at the end of 5 years? If the profit rate is 10%, how much amount? So basically you have to find P using this formula, and as you can see in this formula it will becomes P equal to F over 1 plus I to the power n, right? In other words, here if you increase here, basically you can see here that the number now will be less, right? This is what we call it a discount factor. When you are calculating a present value, future value will decrease, remember, always. Your answer should be less than your F. So whenever you calculate your P, it should be less than. Why it is less than? Because we already said that money today is not same as money in the future. So in present it is less than the future amount. So what is that amount? Using this formula, it is 31,040. Now this for 31,000 comes from this number, we call it discount factor, and this number depends on I and n. Okay, if you increase I, this number will decrease. So there is an inverse relationship. When you are calculating a P, it will decrease, and that decrease depends on I and n. A uniform series, if you have, for example, what do we mean by uniform series? How do we identify a uniform series? That when a cash flow occurs in consecutive interest, consecutive, there should be no break. Consecutive means 1, 2, 3, 4, 5. Consecutive, there should be no break between them, and it is same in each period. If you have these two scenarios, then you can use this formula. Okay, if it is not, if there is a breakup in the time period, then it becomes irregular series. We have different ways of solving for irregular series, but if you have a consecutive and same amount of a every year, a, remember what is a. Now if, let's say, a is given and you are required to calculate p, this is the formula as shown in the bottom, either p or a, this is the relationship. Okay, so how do we calculate it? Look at this example, whether a is given or p is given. Now let's look at this example. A chemical engineer believes that by modifying the structure of a certain water treatment polymer. Remember, we said before that purpose of engineer chapter 1 is to give new ideas, right? Let's say you gave an idea that if we modify a structure of certain treatment polymer, what would happen? That the company would enter, the earn extra 5,000 per year. So this is the principle we call it alternative principles, right? In engineering economics. What important is the alternative with this decision. With implementing this decision, what would happen to a company? They will earn extra $5,000 per year at an interest rate of 10% per year. How much company should spend on this proposal, this project? Okay. So this is a scenario. How much we should spend if we want to get 5,000 profit every year for 5 years. So basically, or in this case, we have given A is given. If we have a profit of 5,000 every year with this proposal, what should be the amount this company should be approving for this project? As you can see here, 5,000 per year means A is given, and you have to calculate an P, and then you can use this formula in the bottom. I is given, N is given, and A you can use it to calculate. This is an example of a uniform series. Remember how to identify a uniform series. If there is something every year, annually, per year, it means it's a uniform series. Per year, annually, and use this formula for P or A. If it is F and A, relationship is different. If you have a uniform series where you have to find F or A is unknown, could be anything, right? But relationship between F and A, this is the formula. How do we calculate it? Look at this example. Another example here, an industrial engineer made a modification to a chip manufacturing process that will save our company 10,000 per year. Remember, now what is the saving? Not a one-time saving. Remember, it is per year saving. So per year means 10,000 each year. 10,000 here, 10,000 here, for whatever the total, right? For 7 years is the project life. N is 7. How much will the saving in it will worth? What will be the value of this saving at the project completion? And whatever saving you get, remember, you will invest them at 10%, sorry, 8%. Whatever you're saving in year 1, it will not sit, it will increase at 10%. This will increase at 8%, all of them. So what will be the accumulated effect? How do we find out? Using this formula, F equal to A, you can find out F. You can have a calculator, you can practice. Now these are just an example of table. We will not be using the tables, but now with calculators you can easily solve it. But for example, if a table is given, this table is for 12% interest rate, and you can apply it for any series. You may have a single payment series, or you may have an equal payment series, or you have a gradient series. Okay, it depends on the question and what is given. For example, in this case, yes, equal payment means uniform. Yes, uniform series. So I'll not be using the tables, it's the same thing. You can use the formula. These are the list of formulas which we'll be using. So as I said before, we'll be using F equal to P or P equal to F, this formula. This is for single payment series, or F equal to A for equal series, or A equal to F. It's the same one. Basically, it's This is just a one formula. This is just 1, 2, and this one is 3. P equal to A. So these are the three formulas you'll be using in this chapter. Gradient and other we will not be using. If P or A or these are basically three formulas. The same thing. These formulas for gradient will not be discussing, right? But concept is same. So only just for your knowledge, gradient series, but we will not be solving them. Okay, so mostly we will cover these formulas. So these are not six formulas, these are basically three formulas which you can use. One is for single series and one is for uh, equal payment series with F and A relation, and one is for P and relation. The rest of this chapter is exercises. You can solve a questions. 3.5 already we discussed. If you look at a question, this is how you solve it, F, P, and you can find any missing number. Okay, this is how it will be given in our solutions, right? 24,000, for example, if you have a given information, right? F is 24,000, which is given like this one. Okay, and 1 plus I to the power n, which is this factor, which is, if you can plug in the number 1 plus I to the power n will become this number, and this is your answer. Sorry, sorry, in this case not 1 plus I to the power minus n, basically this one in P scenarios, because we are calculating a P. Here we are calculating an F, so using basically the same formula in each of them, just a calculation you can practice. This is same thing for equal payment series, just an additional slide. When A is given, for example, sometimes you have to find out, we call it a sinking fund. This is just another name. Let's say you want to return a loan. It says here that what should be the amount you must save every year to return a loan. We call it sinking fund. How much amount of money you deposit every year to return some amount in the future. Okay, if something is due in future, how much you deposit every year to repay that amount. We call it sinking fund, and this is the formula. So these are the exercises. Their solution is there. For example, if you look at a question 3.2, 3.1, these are only with simple interest. If you look at a question, I will share the book now. If you look at a question of, let's say, 3.1, again, this is the only way is to solve more and more questions. I'll also take some sample question today to solve. Now, if you look at this question here, it says here, if you open a saving account that earns 6.5% simple interest. See here in the question, it's mentioned clearly. Interest rate is simple. Okay, if you look at next question, it says 8% simple interest. If you look at 9.3, it says 9% simple interest. Okay. Now, but if you, for example, if you look at this question, 4% interest. So if you see like this one, it is compound interest. Understand the difference. Let's say here it says 8% interest annually. Nothing is mentioned, so it means you have to use compound interest. It's very important. Look at this question. This is also compound interest. Is it clear what I'm saying? Look at this one. It says here 10% per year. Let's look at this question 3.9. If you look at this question, the average price for the new home is 520,000. If the new home price are increasing at a rate of 10% per year, how much will a new home cost in 6 years? Now, how can we solve this question? Understand this one here. The average price, this is what the price now. Remember, 520,000. Can you tell me, is it P or F? What is this one? It is P. And okay, 520,000. And prices are increasing every year 10%, 10%, 10%. Let's say you want to buy this house after 6 years. What will be the cost of this house after 6 years? Remember, so it means you have to find, what do you have to find? What is the requirement? What do we have to find in this question? We have to find F. And which formula we have to use? F equal to P times 1 plus I to the power n. The rest is easy. Yes, it is compounded. That's what I said. In practical, in real life, whenever interest is mentioned, it is compound interest. For our book, if there is any simple interest, it would be mentioned in the question already that the interest rate is simple. Okay, let's look at the next question, 3.10. Their answers are on the slides, you can check. 3.10, it says, what will be the amount accumulated? Can you tell me what is required? What do you mean by this word? As we said that, what will be the amount accumulated by each of these present investment? Understand, look at the information. So it means what is 4,000? It is a present investment. How much it will be in 6 years? Interest rate is 7% compounded annually for part A. P is 4,000, N is 6, I is 7%, and you are required to find out F, basically how much amount accumulated. What will be the total amount after 6 years for part A? Is it clear? 3.9, is it clear? As I said that the formula is easy. For a single payment, F equal to P times 1 plus I to the power N. Any question on part A? Next one, if you look at question 3.11, what it says, 3.11, it says here you are interested in buying a piece of a real property. Real property means land or building property, a car that could be worth 300,000 in 8 years. Imagine you have a chance, for example, you know that someone is selling you a property, car, machine, anything, that the value of this car after 8 years would be 300,000. After 8 years is 300,000. What should be the price you are willing to pay for this property? So what is 300,000 in this case? Is it P or F? Yes, we should find P. Yes. And then Why we need to find P? It says that if I invest in a bank or in any project, I will get a profit of 10%. So at least I want to see how much I should be paying for this property minimum. You may negotiate, but that is the minimum point you need to have. So what you will do, you will find out the value of P, which should be less than 300,000, whatever amount is. Okay, same thing in the next question. It's very clearly says what is the P present worth of these future payments. So F is given, right? What is the P of this amount? F is given, interest is given, so it's easy. Is it clear? Thirteen is same thing. For an interest rate of 12% compounded annually, determine the following: how much can be lent now? It means what is the missing amount? P or F? For 3.13, how much can be lent now? It means we have to find P if 13,000 will be repaid in the end or at the end of 5 years. So it means at the end of 5 years, someone will pay us 13,000. So what will be the value of P? So we can find out using same formula. Easy. So I'm not solving because solution is there. Next one, it says how much will be required in 4 years. Look at this one. How much will be required in 4 years? But why? Because you to repay a loan. You took a loan. So F is, you have to find out this is the loan, which is P, and then the rest is easy. Okay. Now look at next question. How many years will it take an investment to double if interest rate is 6%? Now understand in this case how to solve these type of questions. 3.14. How many years will it take an investment to double? Means if you have P today, how long? P means present value. Today is 100, for example. How long will it take for us that it will become 200 if it is deposited at 6% compounded annually? So how can you solve it? You have P and you have 2P, right? Is it clear what I'm saying? Yes, please. Is it clear? What is required? Yes, F equal to 2P. Yes, thank you. I will explain. Let's look at this example. Now, for example, I have 100 today. Let's say this is the time 0 today. Time is in, let's say, year 0. Now, let's say the question says how many years will take us so that this amount will become double. What be the value of n here? How many years will take us so that this amount will become double, right? If you have, in other words, if you have p today, how long will it take us for us to that this becomes 2p, right? We know that this is our f, right? So same thing here. So this one will also will become f, right? So you can, if nothing is given, for example, it says you can use the same concept, the doubling concept, and then you can solve. We know the formula, which is f equal to p times 1 plus I interest rate whole power and now we have all the numbers. F is p, sorry, f is 2p, then you have p already is there, and you solve it for n. I is given. Clear? I hope you can solve this equation. Yes. So what I suggest you is to solve these questions, and the next class we will practice or we will discuss. If you have any problem and any question, I will explain. But for me to explain, I need you to solve these questions by yourself, right? So list of questions are mentioned in the slides. Only those questions you can practice. Okay, since all are not difficult, easy. Formulas will be given in only you have three formulas. So what is difficult? So only you have three formulas. So I don't think it will be given. So you can just, with practice, you will remember. So this is a one formula, f equal to p 1 plus I to the power n. If you have a compound, and if it is simple, you use this one. Only simple, we have just three questions. This one we already solved these questions. Just look at them, right? Sometimes I is not given. How to find an I? Like in 3.8 question, you have to find I, right? From a given questions, you can find it. Okay, so look at these questions. So this is the formula with f and a. Other formula for every question it is given, or in other words, these are the formulas given. In exam, I don't know, maybe they will not be given. So basically you have just three formulas, so it's not difficult. You can remember them. So these are the list of the questions which you will be solving. Okay, so this is end of our chapter and end of our time as well. So solve these questions in this week. And next time in our class, if you have any question, we will discuss, or else we will move it to the next chapter. Okay, so that's it, end of our time. Thank you very much. If you would like to leave, you may leave. If you have a question, I am available. You can ask me a question.